So till now I have configured IP address only, exclude unassigned. On router number 1, you can see on fast Ethernet 0/0 I am running this IP address 192.168.10.1, and on serial 2/0 on WAN link I am running this IP 1.1.1. Apart from it, I have not configured netting or default route, right? So we will configure default route and netting here. On router number 2 also you can verify the IP, so IP interface brief exclude unassigned, right? On router number 2 LAN interface I am running this IP 10.2, and on WAN interface 2.2.2.1, and router number 3 so IP interface brief exclude unassigned, right? On LAN interface I am running dot 3, and on WAN interface 3.1.1.1. So as you know, on PC number 1, let's say if I will define default gateway, what this one 192.168.10.1, right? Then PC 1 can access internet via router number 1. If I will define this default gateway on PC number 1, then PC 1 will reach to internet via router number 2. If I will define this IP address as default gateway to PC number 1, then definitely PC 1 will reach to internet via router number 3. But as I told you in last class, that we are not going to define physical IP address of default gateway. We will create virtual IP address with the help of HSRP protocol, and we will define that virtual IP address as a default gateway on LAN users, right? So this IP address is going to be my virtual IP address. Okay, so from R1 you can see I am able to ping ISP ping 1.1.2, right? From R2 ping 2.2.2.2, done. From R3 ping 3.3.3.2, done. But I cannot ping 8.8.8 because default route is required here, right? So let me configure one default route on all edge routers first. IP route 0.0.0, 0.0.0 and 1.1.2. Now do ping 8.8.8. Now I am able to ping 8.8.8 from WAN interface, but again I cannot ping 8.8.8 from LAN interface. For that I have to configure translation. So let me configure PAT. On serial 2/0 IPNAT outside exit interface fast Ethernet 0/0 IPNAT inside. Fine. Then I need to create one access list, let's say number 10, and say permit 192.168.10.0 wildcard mask 0.0.255. Then IPNAT inside source match from list number 10 and translate it into the IP address which is running on serial 2/0 and say overload. Fine. Now I can ping 8.8.8 from LAN interface also, ping 8.8.8 and say source fast Ethernet 0/0. You can see, right? Ping is working. I need to do same thing on router number 2 also. So let me take you to R2 interface serial 2/0, say IP NAT outside exit interface F0/0 IP NAT inside exit access list number 10 permit 192.168.10.0 0.0.255. Then IP NAT inside source list 10 interface serial 2/0 overload, right? From here I can now ping 8.8.8 from LAN interface, ping 8.8.8 source F0/0. Why I'm not able to ping? Because of default route. So let me configure one default route as well here. Say IP route 0.0.0 0.0.0, next up is 2.2.2.2. Right, now let me verify the connectivity. You can see from LAN interface I am able to ping 8.8.8. Let me configure same on R3 also, interface serial 2/0, say IP NAT outside exit interface fast Ethernet 0/0 IP NAT inside, and then exit IP route 0.0.0 0.0.0 and 3.3.3.2. okay, then access list number 10 permit 192.168.10.0 wildcard mask 0.0.255. Then IP NAT inside source list 10 and interface serial 2/0 overload. Here also I can ping 8.8.8 from LAN interface 8.8.8 and source fast Ethernet 0/0. Done. Clear guys? I'm going to close the console of ISP, and here let me access PC1. On PC1, if I will define any IP address 10.1.1. let's say 10/24, and if I will define gateway of router 1, let's say 192, sorry, here IP address will be 192.168.10. let's say 10/24, and gateway is 192.168.10.1. right? Now this PC can access internet, can ping 8.8.8 via router number 1, right? But what is problem here? If router 1 will goes down, manually I have to change default gateway. Manually I have to change default gateway. Right? Clear guys till here? So now you can see path. 10.1 is the IP address of router 1, and this is the IP address of serial 0/0 on ISP router. Clear? So if R1 will goes down, manually here I have to change default gateway. Otherwise this PC cannot ping 8.8.8, right? So here I am going to define virtual gateway 192.168.10.100/24. Sorry, IP
Sir,
address is, yes.
the destination port is unreachable. Here it's
Destination?
showing destination port unreachable. Here, the last line.
No, this is, because of virtual VPC. Don't worry about this. Ping is working, right? There is connectivity. I'm getting this reply from 1.1.2. Okay, this is because of VPC. Here I am going to define virtual gateway 192.168.10.100. Now this PC cannot ping 8.8.8 because we have not configured this virtual IP address till now. So you can see ping 8.8.8. Again my ping is not working. Why ping is not working? Because PC1 is not able to resolve MAC address of default gateway. So ARP. You can see in the ARP table we don't have any MAC address with the corresponding of default gateway. So now let me take you to R1 and see guys how we will enable HSRP. So we will run HSRP command on interface. Interface fast Ethernet 0/0. This is my LAN interface. Here I am going to say what? Standby and then group number. Let's say group number 10, or I can use any group number 1, and then IP. After that virtual IP address. What virtual IP address you are going to configure here? 192.168.10.100. Right? That's it. This is configuration. How to verify? So standby brief. So you can see here by default, as I told you, priority will be what? 100, and for now active router is unknown and standby router is also unknown, but after 10 seconds this router will become active, right? And priority is 100, group number is this one, virtual IP address is this one, right? Standby router is unknown, and now you can see state move from standby to active. Now this router is active. You can see active router is local router and standby is still unknown, right? Because this router is not receiving any hello message of HSRP from their neighbor, from any other router, right? Because of that standby router is unknown here. Now if I will ping again 8.8.8, will ping work? You can see ping is working now, right? Ping is working now because now R1 is responding to ARP request. So ARP. So ARP. Here you can see we have one MAC address with this IP address, gateway IP address. So this is HSRP configuration on router number 1. We can check detailed configuration as well by running command so standby. So standby, see the output here. First of all, state of this router is active. State of this router is active. Virtual IP address is 192.168.10.100. Virtual MAC address is, as I told you, virtual MAC address, these value will be always same, and last two value will be what? Group number. So my group number is 1, so that's why you can see in last MAC address is 01. Okay, then hello timer is 3 seconds, hold on time is 10 seconds. Next hello message, it is going to send next hello message after 1.520 seconds. By default preemption is disable. Active router is local router, and standby router is unknown. Priority is 100, and this is group name. Clear, guys? Clear?
Clear.
Okay. Now I am going to enable HSRP on router number 2. Again, interface fast Ethernet 0/0. Say standby, group number 1, and virtual IP address 192.168.10.100. Right? Again, here I can run command show standby brief. So you can see standby router is unknown now. Soon these router are going to exchange hello messages, right? Soon router 2 will receive hello message of router 1, and router 1 will receive hello message of router 2. Then router 2 will become a standby, because as I told you, by default preemption is disabled. Otherwise router 2 should become active router, right? But preemption is disabled and active router is still there in this group. So router 2 is going to become a standby router, right? Standby. And here you can see active router is 192.168.10.1. This is IP address of R1, and standby router is local router, and virtual IP address is this one. By default, again, priority is 1, group number is 1. But by priority is 100 and group number is 1. Here also group number is 1, priority is 100. These are by default. Now, when I will enable HSRP on router number 3, then router number 3 will be in listening state, or router 3 will become a standby router, guys. So for standby preemption is enabled. So router 3 have higher IP address than router number 2. So router 3 will become what? Standby, and router 2 will be in listening state. Router 2 will be in listening state. So let me configure R3, HSRP on R3. So this is output of show standby brief command, and here we can check detailed information as well, like by running command show standby. So here also you can see the output. State is standby, virtual IP address is this one, virtual MAC address is same, hello time 3 seconds, hold on time 10 seconds, preemption is by default disabled, active router is 192.168.10.1 whose priority is 100, and standby router is local router, priority over here is 100, and this is name of group. Now let me enable HSRP on router number 3. So on R3 interface fast Ethernet 0/0, say standby, group number 10, sorry, group number let's say 1, and IP 192.168.10.100. So standby. So standby, we can say brief. Standby router is 192.168.10.2, but now you can see this router is standby because router 3 have higher IP address. Priority is by default same on all routers, but router 3 have higher IP address. Because of that, router 3 have become a standby, and router 2 is in listening state. So here now I can run command show standby brief. You can see this interface, priority this one, group this one, state is standby, active router IP address is 192.168.10.1, means router 1 IP address, standby is local router, and virtual IP address. Now on R2, again if you will run this command show standby brief, you can see state of this router is listening. So even let's say if we have some more routers, router 4, router 5, so all other router will be in listening state. In one group, only one router will be in active state, and only one router will be in standby state. All rest routers will be in listening state. Right, guys?
Why the 10.3 become active?
Yes. I am also that same question. I have.
10.3 is not active, na?
No,
10.3 is
standby.
because router 3 have higher IP address.
Because here that in HSRP you are saying that the preemption is disabled.
Preemption is disabled for active router. Preemption is enabled for standby. How many times I told you this? Preemption is enabled for standby. Preemption is disabled for active router only. So router 3 have highest IP address than router 2. That's why router 3 have become what? Standby. If any other router will come in this group with higher IP address, that router will become standby. because preemption is enabled for standby and listening. So that's why router 3 is my standby router. If you want router 2 should be your standby or should be active, you can change priority there.
How
Fine.
do we know that for standby preemption is enabled?
We cannot check that. I am telling you preemption for standby is enabled. There is no any command to check, preemption for standby.
Okay.
But preemption is enabled, that's why router 3 became standby. Otherwise router 2 will be standby, na?
Can you give now show standby?
Here we are able to see preemption is disabled only.
Then
Huh?
This is preemption for active router. On R3, on
yes, sir.
R3 you want to run show standby command. See. Anything else? Now,
This description is belongs to that R3 only, right? Whatever that show this one.
this one. No, here we
Show
have
standby.
information of active router also, no? We have
Yeah,
priority
yeah,
of active router.
yeah. But for this preemption disable means this is belongs to that R3 or R1.
On R3 preemption is disabled. On all routers by default preemption is disabled, and guys this is preemption for active router, not for standby router. By default, and you cannot disable even preemption for standby router. Preemption is enabled for standby router in the inbuilt configuration in the iOS, so we cannot change that.
No, for that normally that HSRP that preemption is disabled, right?
Right.
Then if we have configured for that router one, if we configure this HSRP, after that we configure that R2, right? That
Hmm.
HSRP. See, for that also it should be disabled only, right?
Right.
Then how that election was happened, for that standby, if we disable means.
My god, I am telling you preemption is disabled for active router only, not for standby, brother. For standby preemption is enabled.
Is it for active router election? For
For
electing
all
active
routers.
router, preemption is disabled. For standby router election, preemption is enabled.
Yes. And preemption for active router will also not work. Even you will enable preemption over here, then also preemption will not work. So preemption never work with default priority. So if I will see here, if I will enable preemption on router number 1, interface F0/0 standby group number 1 and say preempt. So standby. Now preemption is enabled over here. On router number 2 also I am going to enable preemption. So this is preemption for active router. Standby group number 1 preempt. So standby. Preemption is enabled on router number 3. So sorry. Config T interface F0/0 standby group number 10 preempt. So standby. Preemption is enabled, but still
Group,
which router is active router?
group number 1, you gave 10.
Yes, yes. Group number 1.
preemption is enable, right? So now rotor 3 should be active rotor, but you can see so standby brief. Which rotor is active rotor? 10.1 means rotor 1. So preemption for active will not work with default priority. But on R3, if I will change priority, interface F0/0, standby group number 1 and priority, let's say 110. Now you can see this rotor is my active rotor. Active rotor is local rotor. And which rotor is a standby rotor? Which rotor will become a standby here? Rotor 1 or rotor 2? Rotor 2 have highest IP address than rotor 1. So rotor 2 is my standby rotor, rotor 3 is active rotor, and rotor 1 is in listening state. Now here you can see between rotor 1 and ISP we have 8 Mbps link. Between rotor 2 and ISP we have 4 Mbps link, and between rotor 3 and ISP we have 2 Mbps link. So this is my primary link, this is my secondary link, and this should be my backup link, right? So how I will configure the scenario? On rotor number 1 I should configure higher priority. On rotor number 3 I am going to set priority what? Interface F0/0, say standby group number 1 priority, let's say 105. On rotor number 2 I am going to set priority, let's say 110. Interface F0/0, say standby group number 1 priority 110. And rotor number 1 I am going to set priority 120. Interface F0/0, say standby group number 1 and priority 120. So now rotor 1 will become active rotor, rotor 2 will become a standby rotor, and rotor 3 will be in listening state. So standby brief. So this rotor is active rotor, standby is unknown, soon rotor 2 will become a standby rotor. Now you can see, right? And on rotor number 3, so standby brief, this rotor is in listening state. Clear? So again from PC1 if I will trace 8.8.8.8, you can see my traffic is going via router number 1. If router 1 will goes down, interface F0/0 says shut down. Now router 2 will become active router. So if you will trace again to 8.8.8, you can see two dot 192.168.10.2 IP address of router 2. That means now my router 2 is active router. On router number 1, so standby brief. Here you can see active router is also unknown and standby router is also unknown. So whenever you will see this problem, right, active and standby both are unknown, that means there is no connectivity between two default gateway. So here I have shut down this interface F0/0, right? So that's why we are able to see active is unknown and standby is unknown. Sometimes you will see both router will show you active. Means if R1 is also saying I am active, router 2 is also saying I am active. That means both routers are not able to exchange HSRP hello messages, right? So if R1 will not receive any hello message from any other router, right, then R1 will say what? I am active and standby is unknown, right? But on router number 2, so standby brief. You can see local router is active router and standby is router number 3. Again when router 1 will come up, router 1 will become what? Active. Interface F0/0 say no shut. Active router is router 2, and now you can see the active router is local router. Standby router is router number Standby router will be router 2, not router 3 na. Router 2. Clear? So this is HSRP. Any question? See, ping is working. Yes. Any question? Can I configure VRRP now?
If preempt is enabled, whatever router having higher priority, that will become active, right?
Yes.
Am I right? Okay.
Yes. Clear? Now, okay. See, now PC1 is able to ping 8.8.8. Yes.
We need to configure preempt in all the routers, or the router, what we can configure in only one router also.
No, no. You have to configure it on all routers.
Preempt on all the routers.
Yes. Now, if link between R1 and ISP will goes down, then what will happen? If link between R1 and ISP will goes down, let's say serial 2/0 shutdown. Now, so standby brief. Still, which router is local active router? Local router means R1. Then PC cannot ping 8.8.8. Again, destination host unreachable. Right. So what is happening? Router 1 is my active router in this scenario, but there is no connectivity between ISP and R1. So this time, if LAN interface will goes down, right, then only R2 or R3 will become active, right? If this link will goes down or ISP will goes down, right, R1 will be my active router still, right? So in this scenario, what I need to do, I need to track this link. I can track this link. I can tell to router, please track this link if line protocol of this interface is up. If line protocol of this interface is up, let's say this link will goes down, then line protocol of 0/0 on router number 1 will down. So if line protocol will goes down, right, please decrement priority by, let's say 20. So here configure priority is what, 120. Here configure priority is what, 110. Here configure priority is what, 105. So if track will goes down, it will decrement priority by 20. Then what priority will become here? 100. So automatically router 2 will become what? Active router. Automatically router 2 will become what? Active router. Clear? If I will decrement priority by 5, then what will happen? If I will decrement priority by 5, whenever track will goes down, please decrement priority by 5. So configure priority is 120, it will decrement priority by 5. So what will be priority over here? 15. 115. So still you can see router 1 have higher priority. So still router 1 will be my active router. So make sure when you are tracking the link, you should configure, correct decrement in priority. So let me show you this also. Like here you can see PC1 is not able to ping because my router 1 is active router. Router 1 is my active router, but link between ISP and router 1 is down. So IP interface brief. This link is administratively down. So first of all, I am going to up this link interface serial 2/0 say no set. Right. Again from PC1 you can ping and ping will work.
What is the default decrement value for the track?
Okay.
So what is the default decrement value for the track?
10. Default decrement is 10. Yesterday also I told you this in theory part. So now I am going to track serial 2/0. So see command is interface f0/0, say standby, group number 1 and track. And after that we can mention track number. Let's say track number 1. After that decrement. If you will not define decrement, it will decrement priority by 10. So now you can see here, so track. So my track is interface f0/0 standby number 1 track.
I think we have to define that yes, which interface?
Standby track interface serial 2/0. Two slash zero. This is command, right? Now you can check track. So track. So my track is up. Line protocol is up, right? So track 1 via HSRP tracking line protocol of serial 2/0. Line protocol of call of serial 2/0. So if this track wheel goes down, it will decrement piety by 10. So here piety will become what? 110. Okay, but it should decrement priority at least 11, right? So router 2 can become active router. Otherwise on both router priority is same, but again router 2 have higher IP address, so router 2 will become active router. So what I am going to do, I am going to again down interface serial 2/0, interface serial 2/0 say shutdown, and so track. So you can see my track is down. So whenever track will goes down, it will decrement priority by 10. So standby brief. Here priority is what? 110. And so standby, you can see configured priority over here is 120 and current priority is 110, because it have decrement priority by 10 because track is because track is down. Again when track will come up, it will add priority by 10. Interface serial interface f0/0 standby number 1 track and say decrement priority by 20.
Serial 2/0 track.
So track is down because serial 2/0 is down. Interface serial 2/0 say no set. So standby brief. Priority is what? 120. Now if serial 2/0 will goes down, it will decrement priority by 20. So see interface serial 2/0, again I am going to say shutdown, right? And so track is down because of that, so standby brief. Priority over here is, so it have decrement by 10, so standby.
You didn't give the command correctly. You didn't mention serial 2/0 in the track command.
Oh, interface f0/0. Let me remove this command. no to this, and so track, it is tracking serial 2/0 line protocol, and this track is down. Interface serial 2/0, say no set, wait, so standby brief, here priority is 100, this router is active. Okay, so standby. Configure priority and current priority both are 120, right? Now I am going to decrement priority 20 whenever track will goes down. What I want, it should decrement priority by 20 or by 11 whenever track will goes down. See, in this scenario, what I want, if router 1 is active and there is reachability between ISP and router 1, then router 1 should be my active router, router 2 should be my standby router, and router 3 should be in listening state, right? So here priority is 105, here priority is 110, and here priority is 120. So if I will decrement priority by 11 whenever track will goes down, then here priority will become what, 109. So you can see on router number 2 we have what priority, 110, here what priority we have, 109. So router 2 will become what, active router, and router 3 will become standby if router 1 will goes down. Fine, so let me do that. Here again on R1, do so run interface f0/0. First of all, I am going to remove this command. Say no to this, and then say standby number 1 track decrement and decrement, here we can say decrement by, let's say, 11. This is command. Now if serial 2/0 will goes down, interface serial 2/0 says shut down to this interface, track will goes down, you can see track is down, and this router move from active to speak state. Now here you can run this command, so standby brief. So active router is now router number 2, active router is router number 2, and standby router is still router number 1. Why? Because on router number 1 we have what priority, 109, and router number 3 we have what priority, 105. So router 1 is standby router. Clear? And see the output of so standby command. Here configure priority is what, 120, and current priority is 109 because of track, because my track is down. Again when track will come up, interface serial 2/0 say no set, right? Track will come up, and on stack will come up, it will add priority 20. So standby, you can see here priority now is 120, and because of this, so standby brief, this router is active router. Even ISP interface will goes down. Let's say on ISP I'm going to down serial 2/0, interface serial 2/0 say shut down, shut down. Again line protocol of serial 2/0 on router number 1 will goes down, so IP interface brief. Soon line protocol of this interface will be down, right? This is GNSC, that's why it's taking some time. Soon you will see line protocol of this interface will goes down. Okay, now you can see line protocol is down. Because of that, my track is down, up to down. And when track will goes down, it will decrement priority by 20. So this router is now a standby router. Clear? Okay, here priority is 109. So what I want, if link between R1 and ISP, whenever link between R1 and ISP will goes down, R1 should not be a standby router, right? R3 should be my standby router. Then I should decrement priority by, here priority is 120, here priority is 110, here priority is 105. So I should decrement priority by, let's say 20, right? So here priority will become what, 100. So router 2 will become active and this router will become standby. So first of all, on ISP router, let me run noset command again. Interface serial 2/0 say noset. Again line protocol of serial 2/0 on router 1 will come up, then track will come up, and when track will come up, it will add priority by 20. So here by 11. So priority over here is going to be 120. So IP interface brief screwed unassign. Right, line protocol is up, so track. So track is up and so standby. That's why you can see priority is 120, and because of this, so standby brief. This router is my active router. Yes guys. Clear HSRP? Is HSRP clear to everyone?
Yes, sir.
Yes.
Can you do IPSLA?
Okay. See, let's say here router 1 is connected with different ISP. We have connectivity from 3 different ISP. Here router 1 have connectivity from, let's say, ISP1, router 2 have connectivity from ISP2, and router 3 have connectivity from ISP3. So when we will track this link, right, then definitely if this link will goes down, track will goes down and it will decrement priority in priority. But if ISP will goes down, let's say here we have one loopback 8.8.8.8. If this loopback interface will goes down, right, then track will be up here, because track is tracking what, this link, line protocol of this link, right? So if you want to track ISP, now I want to track 8.8.8, that until and unless 8.8.8 is reachable from router number 1, right, then track should be up. If 8.8.8 is not reachable from R1, then track should be down, and when track will goes down, it should decrement priority by 20 or by 10, 11, anything. So for that scenario, what I can do, this is guys inbuilt feature. This is inbuilt feature of track in HSRP, right? For track 8.8.8 from R1, you have to create external track, right? For that, you have to create IPSLA to send ICMP packet to 8.8.8 continuously. So what I can do on R1, first of all, I am going to remove this track configuration, interface F0/0, and say no, do so run interface F0/0. I'm going to remove this command, right? And now I'm going to create one IPSLA, say IPSLA, and then SLA number is, let's say, 10. Here I'm going to say echo ICMP echo. ICMP echo request means I am creating IPSLA for ICMP echo request. It will send one echo request to 8.8.8, right? From which interface? From, we can say, source interface serial 2/0, right? Now here if you will debug IP ICMP, Here we are not able to see any ICMP message. Actually, I have created SLA. Now I have to schedule this SLA. To schedule this SLA, you need to run this command IP SLA schedule, and then SLA number. SLA number was 10 or 1?
10.
10. Okay, so 10, and then we can say, you know, start time when you want to start this IP SLA. So let's say now I want to start now, and for till when you want to run this. So say for life forever, life forever. And now you can see it have started sending ICMP echo request to 8.8.8. On ISP also you can see it is receiving ICMP echo request message. It is generating reply to 8.8.8, right? And now I am going to call this IP SLA with track. So here I can create one track number 10, IP SLA number 10, reachability. Fine. Now show track. My track object number 10 is up or down? Up. Why track is up? Because 8.8.8 is reachable. If I will down this interface on all, if I will down loopback interface here, interface loopback 1 says shut down to this interface. Now on router number 1, so track, soon track will goes down, ping 8.8.8, right? So ping is not working on all, so track, my track is still up. Actually it's taking some time, right? Now you can see your track goes down. So what we can do here, we can configure, you know, frequency IP SLA 10, NTL redealing we cannot modify. Okay, say no IP SLA 10 and say IP SLA 10 again, ICMP echo to 8.8.8 from source interface serial 2/0, and here I can set frequency 5. So after 5 seconds it will send one ICMP packet to 8.8.8. Now again I have to schedule this IP SLA. So say IP SLA schedule number 10, then life or start time, now life forever. So track. So my track is done. Now I am going to run no such command here on loopback interface of ISP. So track will come up. You can see now track is up. Track is up. And now I am going to call this track with HSRP. So let me take you to interface fast ethernet 0/0, and here I can say standby group number 1 track number 10, and decrement in priority by, let's say, 20. Now this is configuration. Now see on ISP again I am going to run no shutdown command on loopback interface. So on router number 1 track will goes down. Track will goes down. Here you can see track is reachability, there is no reachability. Now show track. So track is down. So if track will goes down, it will decrement in priority by 20. So standby brief. So here you can see priority is what, 100. So active router is router number 2, standby router is router number 3. Right, again if track will come up, again if there is reachability from serial 2/0 to 8.8.8, then track will come up. You can see track is up. Now again HSRP state is speak to active. Now this router is my active router, so standby brief. Okay Dhana.
Okay, sir.
Now can I move to VRRP?
Can we do IPSLA in F0/0 also?
F0/0, this interface,
Yes.
why you will track this interface? If this interface will goes down, it will stop sending hello message now from here.
Source from that interface. Source
From where?
source from F0/0 to 8.8.8.
Yes, you can define this interface also as a source interface. Yes, of course. From this interface also we have reachability to 8.8.8 now, so we can define this interface also as source in IPSLA.
Okay, sir.
In same scenario it will work fine, right? Now VRRP is also guys exactly same like HSRP, but again VRRP is open standard and HSRP is Cisco proprietary protocol. So I am going to remove HSRP configuration from router 1, 2, 3. So first of all, on router number 1 I am going to say no IP SLA 10 and say no track 10 also. I have removed track configuration and IP SLA configuration. Then interface F0/0 do so run interface F0/0. I'm going to remove these all commands, say no to this. Fine, and do so history. I'm going to copy. Oh, priority is different now on each router. Interface F0/0 do so run interface F0/0, say no do so run interface F0/0. Okay, so run interface F0/0. So default configuration. Okay, interface F0/0 do so run interface F0/0. Let me remove these all command from this interface also. No, I have removed HSRP configuration from all routers, from router 1, 2 and 3. So standby. Now you can see we are not able to see any output. So again PC1 cannot ping 8.8. Ping is still working. So ARP. Clear ARP. So ARP. right? And now ping 8.8.8. Fine. So see now how you will configure VRRP protocol here. Again on router number 1, go to LAN interface app 0/0 and say VRRP, then group number, let's say 1, and then IP. And guys, if you want to change timer or those things in HSRP, command will be this one: standby, group number, and then timer. This is command. Then you can define hello time, then you can define hold on time. Like this, you can change timer in HSRP, right? VRRP group number 1, IP 192.168.10.100. This is VRRP configuration, right? On router number 2 also, interface F0/0, VRRP IP 192.168.10.100, VRRP group number 1, IP this. On router number 3, interface F0/0, VRRP group number 1, IP 192.168.10.100, right? So here I can run so VRRP brief. So this router is master router. Why this router is master router? Because this router have highest IP address, and priority on all router is, you can see by default, 100. So VRRP brief. This router is backup router. Master router is 192.168.10.3. On router number 2, so VRRP brief. So configuration is exactly same. In VRRP, one router will be active router, and all other router will be in backup. All other router will be backup router. So when active will goes down, again backup router will come up, will become active router. Means router who will have highest IP address if priority is same on all routers. And so VRRP state is backup, virtual IP address is this one, virtual MAC address is, again you can see this one, right? Preemption is by default enabled. Preemption is by default enabled in VRRP. Master router IP address is 10.3, priority is this one, right? These are same output. Here also on router number 1, I want router 1 should be my active router. So interface fast Ethernet 0/0, I can say VRRP group number 1, priority 120. So you can see the log message. Now this router is my master router. So VRRP brief. Right. What I want, when R1 will goes down, R2 should become master router. So on R2 I am going to set priority what? 110, let's say. Interface F0/0. VRRP group number 1, priority. On router number 3 I can set 105. VRRP group number 1, priority. Right. Again from PC1 I am going to ping 8.8.8. You can see ping is working, and router 1 is my active router. So here we can trace as well. Trace 8.8.8. Right. So traffic is going via router number 1. When R1 will goes down, interface F0/0 says shut down. Which router will become master router? Router 2. So from PC, again if you will trace, right? So my now traffic is going via router number 2. Again, if router 1 will come up, router 1 will become master router. So by default preemption is enabled over here in VRRP. Then we have last protocol, that is GLBP. So see what is problem in, yes.
If you have two groups,
If we have two groups,
so how it works?
For two group, how it will work? Same it will work like how it's working in single group. Let's say guys, here I have single group, group number 1. In group 1, this router is master router, this router is backup router, this router is backup router. Here priority is what? 120. Here priority is what? Here priority is 110 and here priority is 105, right? So for all these user, router 1 is my master router, right? That means these all user will access internet via router number 1. So let's say what I want that for these two user, for these two users should be able to access internet via router number 1, and this user should be able to access internet via router number 2. So what I can do, I can create one more group here, group number 2, and in group number 2 here I will set priority what? 105. Here I will set priority what? 110, and here I will set priority what? 120. So for group 2, which router is active? Router number 3. Let's say here I have defined virtual IP address 192.168.10.100. Here I have defined virtual IP address 192.168.10.200. So I will define this default gateway to PC number 3 and this default gateway to PC1 and PC2. So it will work same. So if you want to achieve load balancing, let's say here we have some user in VLAN 10 and we have some user in VLAN 20. So for VLAN 10 user, I want to write router 1 should be my active router. For VLAN 20, router 3 should be my active router. So for that scenario, you can create multiple groups. Working will be same. There's no any difference when we have multiple group. Okay. Let's say here on router number 1, interface F0/0, VRRP group 10, IP 192.168.10.200. Right, let me copy this command. Okay, and here let me set priority as well. VRRP group number 2, priority 100, right, and do okay. Now R2 VRRP group number 2, IP 192.168.10.200, VRRP 2, priority 110. On router number 3, VRRP group 2, IP 192.168.10.200 and VRRP 2, priority 105. So you can see on router number 1. Now if I will run command show VRRP brief, this router is master router for which group? Group 1, and this router is backup router for group 2. On router number 2, so VRRP brief, this router is master router for group 2 and this router is backup router for group 1. Now on PC1, I'm going to define what default gateway? Same 192.168.10.100. On PC2, I'm going to define 192.168.IP 10. Let's say 20/24, and here I will define default gateway what? 10.200. So PC2 will access internet via router number 2. From here, if you will trace 8.8.8, see, traffic is going via router number 1. From PC number 1, if you will trace 8.8.8, traffic is going via router number 1. So if we have multiple group, then also working will be same, right? There is no any difference. Fine. Can I remove VRRP configuration?
Yes, sir.
Okay. So interface F0/0, say do so run interface F0/0. Say no to this command, no to this command, and no to this command. On router number 2, config T, interface F0/0, at no, do so run interface F0/0. So guys, in HSRP and VRRP, in one group only one router was active and only one router was in a standby, right? But if I will talk about GLBP, in GLBP there are two types of router. One is AVF and one is AGF, right? So you need to understand only these two types of router in GLBP. And GLBP by default perform load balancing. Let's say these all three gateway are up available, then it will perform load balancing. Maybe it will forward traffic of PC1 or first packet from router number 1, second packet from router number 2, and third packet from router number 3. So in GLBP you need to understand how this protocol is going to perform load balancing, right? That is only difference in GLBP from VRRP and HSRP. So do so run interface f0/0. Here I'm going to say no to this command first, then no to this command, and no to this command, and no to this command also. Now one minute guys, let's understand some theory part about GLBP protocol first, then I will come to configuration. Okay, so this is my topology. Guys, again GLBP protocol is Cisco proprietary. You can run GLBP only on Cisco devices. Only on Cisco devices. Now when we will configure GLBP on these three router, one router in a single group, one router will become AVG. One router will become AVG router, and all router will become AVF router. AVG stands for active virtual gateway and AVF stands for active virtual forwarder, right? So in one AVG, in one group of LACP, how many forwarder routers are there? 3. All routers will become what? AVF, right? Router 1 is going to become what? AVF. Router 2 will be also what? AVF, and router 3 is also what? AVF are those router which is going to send IP packet, So in this scenario, all router will be my ABF, means all routers are going to send IP packet. So all router 1, 2, 3, all routers are going to forward packets of these user. And AVG is not used to forward IP packet. AVG is responsible to response ARP reply message, to response ARP request message. Whenever PCs will generate ARP request message, AVG router is responsible to provide MAC address. So what AVG will do, here we have 3 routers, right? So one router, let's say my router 1 is AVG router who will have highest priority and highest IP address, that router will become what? AVG. There will be only one AVG, okay? And AVG router will be also AVF. This is AVF1, this is AVF2, this is AVF3. So we have 3 forwarder in one and one AVG. Now when PC1 will generate ARP request for this virtual IP address 192.168.10.100, AVG will provide MAC address of forwarder 1. When PC2 will generate ARP request, AVG will provide MAC address of forwarder 2. When PC3 will generate ARP request message, AVG will provide MAC address of ABF3, forwarder 3, right? Again, when any other user will generate ARP request, AVG will provide MAC address of forwarder 1. Again, it will come to forwarder 1. Okay, so AVF is responsible for forwarding IP packet, and AVG is responsible to forward to resolve To see here, you can say MAC address of forwarder. So AVG will be also AVF, and router 2 will be also AVF, router 3 will be also AVF over here, right? So this is how in GLBP we are achieving load balancing by default. In a single group, we are achieving what? Load balancing. If any router will goes down, let's say router 3 will goes down, right? So AVG will remove router 3 from their forwarder list, from their active forwarder list, right? Then AVG will provide MAC address of forwarder 1 and forwarder 2 only. Done. All devices, always keep in mind, in GLBP all devices will become what? AVG, and one router will become all router will become AVF, and only one router will become AVG. And when computers will send ARP request message, AVG will generate response. AVG will share the MAC address of forwarder. Clear? If I will talk about MAC address, virtual MAC address in GLBP, so virtual MAC address is 007 0007 0007 B4. Let me check once. GLBP multicast address. Sorry, what we can say?
Virtual MAC address.
This is right. X-axis group number and YY is forwarder number, right? So router 1 is forwarder 1, router 2 is forwarder 2, and let's say router 3 is forwarder 3. So what will be virtual MAC address of forwarder 1? 0007.B4 dot group number 01 and forwarder 1001, right? What will be MAC address of AVF2 forwarder 2? 2. And what will be virtual MAC address of forwarder 3? 3. Here. This is concept of GLBP. Now configuration is exactly same. Let me show you configuration. On router number 1, interface F0/0, GLBP group number, let's say 1, and then IP 192.168.10.100, right? So GLBP brief. Okay, it will come soon in forwarding state. And so GLBP, you can see here that two information. This is information of AVG. This is information of AVG, and this is information of AVF. So there is one forwarder. There is only one forwarder, right? This router is forwarder router, as well as this router is gateway router, AVG, right? In the same way, on router number 2, interface F0/0 0/0 GLBP group number 1 IP 192.168.10.100. On router number 3, GLBP group number 1 IP 192.168.10.100, right? Let me take you to R1 again. On R1, how many forwarder we have now? 2 forwarder, and soon it is going to receive GLBP hello message from R3. Then you will see 3 forwarder are there. There will be 3 number of forwarder. Now you can see there are 3 forwarder, right? So when R1 will receive first packet, it will provide MAC address of forwarder 1. This is forwarder 1 information. This is forwarder 2 information, and this is forwarder 3 information, right? So when ABG means router 1 will receive first packet, first R packet, it will provide this MAC address. To second ARP request, it will provide this MAC address, and to third ARP packet, it will provide this MAC address, right? So what we can do, we can verify it from PC1. From PC1, I'm going to first clear ARP, and let me ping 8.8.8.8. See, I am able to ping 8.8.8, and if you will check MAC address table, sorry, ARP table, so ARP, you can see this is MAC address of forwarder 1, 01, right? If I will clear ARP, and if I will ping again 8.8.8, so this time AVG will provide MAC address of forwarder 2. Now you can check again MAC address, sorry, ARP table, so IP ARP, you can see, right? Again, if I will clear ARP, and again if I will ping 8.8.8, this time AVG will provide MAC address of forwarder 3. So ARP, done. So in GLBP we can achieve load balancing by default, right? After that, again priority configuration, preemption configuration, right? Those are exactly same like HSRP. Both are Cisco proprietary. So here also in GLBP you can see by default preemption is disable. Clear? So this was, guys, all about first hop redundancy protocol. What we call it, FHRP, first hop redundancy protocol. Any question?
How the AVG election takes place?
Highest priority and then highest IP address. Same like HSRP. As I told you, election criteria is same.
Why you are clearing the ARP and checking?
If I will not clear the ARP, so it will store ARP entry for 4 hours in their ARP table. Na? So for 4 hours, PC1 will communicate via router number 1. After 4 hours, it will generate ARP request. So that's why I was clearing ARP table. Like again, if PC1 have this MAC address of forwarder 3. If PC2 will ping 8.8.8, PC2 will get again MAC address of forwarder 1. PC2 will get MAC address of forwarder 2, sorry 1. So ARP, or we can trace as well, trace 8.8.8, right? If you will trace 8.8.8 from PC1, you can see PC2 is communicating with internet via router 2, and PC1 is communicating via router 2, and PC2 is communicating via router 1. If I will clear ARP table, so again it will generate ARP request message, and it will get MAC address of forwarder 2 now. So this type of load balancing is called round robin load balancing algorithm. This is round robin load balancing algorithm. Router is forwarding one packet from one AVF. First packet to first AVF, second packet to second AVF, third packet to third AVF, then again fourth packet to first AVF. Done.
It uses only one load balancing method or GLBP?
We have three load balancing algorithm. Interface F0/0, GLBP group number 1, and load balancing. We have three load balancing algorithm. By default, round robin. We are not using nowadays host independent, but we are using weighted and round robin. Round robin is by default algorithm. If you will run this command, so GLBP, so here you can see load balancing algorithm as well. Right. So in round robin, it is performing load balancing in which ratio? 1:1:1. It is forwarding one packet from AVF first, then one packet from AVF 2, then one packet from AVF 3. So load balancing algorithm is like this. Let's say you want to forward more packet from AVF 1 and you want to forward less packet from AVF 2, then you have to change load balancing algorithm here, right? Let's say I want to forward 60% traffic from router number 1, 20% traffic from router number 2, and 20% traffic from router number 3. Then we can use load balancing algorithm weighting.
It's based on the device, right? Device load balancing. Load balancing is based on the device. It's not based on the packet, right? From the PC, if you ping multiple times, the packet will go to the same router. If new device is
Yes.
connected, it goes to that other router.
Yes. So until PC1 will have MAC address of ABF1, definitely it will communicate via router number 1. Right. Even we can achieve load balancing in HSRP and VRRP also, but to achieve load balancing there you have to create multiple group. In GLBP, in single group we can achieve load balancing. If R3 will goes down here, if R3 will goes down, then what will happen? Say shut down. Again same thing will happen. PC1 will get MAC address of AVF1, then PC2 will get MAC address of AVF2, again PC3 will get MAC address of AVF1, 2, 1, 2, 1, 2, like this. Now guys, we have last topic, that is access control list. Access control list. So let me perform on a small lab of ACL here as well. No any topology there. So what I can do, I can create one topology here, or let me create topology in packet tracer, it will be easier. 1 minute, guys. People. Okay. R1, R2, let's say we have 3 router. So this is my topology. Let's say this is my HTTP server. This is, let's say, DNS server. And this is PC4, PC1. Here we are using subnet. Let's say 10.1.1.0/24. Here we are using subnet 20.1.1.0/24. Here we are using subnet, let's say 30.1.1.0/24. Right? IP address of HTTP server is, let's say, 30.1. IP address of DNS server is, let's say, 30.2, and IP address of this PC is, let's say, 30.3. Right? IP address of this machine is, let's say, 20.1. IP address of this machine is 20.2. IP address of this machine is 10.1. Here IP address is, let's say, 10.2. Okay, between router 1 and router 2 I will use 12 network, and between router 2 and router 3 I will use 23 network. Okay, so first of all let me configure the scenario. After that we will create scenario to perform ACL. On R1, no, enable config t interface f0/0 no set IP address 10.1.1. let's say 100 255.255.255.0 exit interface f0/1 say no set, and IP address 12.1.1.1 For connectivity, let me run any routing protocol. So let's see router HSRP number 10, and I'm going to advertise all interface network 0.0.0. Interface f0/0 no set IP address 20.1.1.100 255.255.255.0 exit interface f0/1 say no set here, and IP address 12.1.1.2 exit interface f1/0 no set, and IP address 23.1.1.2 255.255.255.0 exit router EIGRPS number 10 network 0.0.0. Enable config t interface f0/0 no set IP address 30.1.1.1 255.255.255.0 30.1.1. let's say 100 exit interface f0/1 no set, and IP address 23.1.1.3 255.255.255.0. Exit router EAGRP yes number 10 and network 0.0.0. So IP route EAGRP. So we have 10 network, 20 network. Okay. Now let's say what I want, PC0 should not be able to communicate with PC2. PC0 should not be able to communicate with PC2. Can I achieve this task with the help of extended ACL? Guys, you know already know what is the difference between extended ACL and extended ACL. Let me discuss again. Let me open that file. So difference is, first is range. After that we can block network, host and subnet. But in extended ACL we can block network, host, subnet as well as services. All services will block. In extended ACL, if you will block IP, you can either you can only block IP with the help of extended ACL. So all other services will automatically blocked. And extended, you should apply extended ACL nearest to the destination, and you should apply extended ACL nearest to the source. Right? Filtering is done on the basis of source IP address base. Right? But here in extended ACL, filtering can be done on the basis of source IP, destination IP, protocol and port number.
What is
Right?
that implemented closest to the source, closest to the destination?
Let's say here PC0 is my source and PC2 is my destination. Right? I want to block communication between PC1 and PC0. So if I am using extended ACL, I should apply it on router number 2. Because see what will happen if I will apply extended ACL on router number 1, if I will block 10.1 to 20.1. So router 1 will block traffic on the basis of what? Source address. It will not check destination in extended ACL. So if 10.1 want to communicate with 20.1, right, communication is blocked. 10.1 cannot communicate with 20.1 also here, right? Or 10.1 cannot communicate with 30.1 also, if you will block 10.1 to 20.1. But if you will apply this extended ACL on this interface, then also PC0 cannot communicate with these two devices, but PC0 can ping to this device server. Okay, because in extended ACL filtering will happen on the basis of source address only. So let me apply it on router number 1. Let's say I want to apply this access list on router number 1. What is my requirement? 10.1 should not communicate with 20.1. So here I will create access list. Let's say number 10. I'm creating extended ACL. Then say deny 10.1.1.1 while karma 0.0.0. That's it. Now you can see here we don't have any other option to define destination. Right? So if I will apply this ACL over here, and then implicit deny is already there in IS, so you have to permit rest traffic, permit any. And now if I will apply this ACL on fast ethernet 0/1 IP access group number 10, let's say direction out. Now here I am going to define IP on PC 10.1.1.1, subnet mask 255.255.255.0, gateway is 10.1.1.100. On this PC 10.1.1.2, 255.255.255.0, 10.1.1.100. PC2 20.1.1.1, 255.255.255.0 and 20.1.1.100. 20.1.1.2, 255.255.255.0 and 20.1.1.100. Okay, now you can see from PC0 I am going to ping PC1, let's say 10.1.1.2. I'm able to ping. Can I ping 20.1? Ping 20.1.1.1. Why ping is not working? Because of access control list. But here I cannot ping 30.1 also. 30.1.1.1 because router 1 is filtering traffic on the basis of source address, right? Whenever router 1 will see source is 10.1.1.1, it will not allow to auth from 0/1 interface, this interface, right? So here I am not able to ping 30.1 also. So what I can do, I can remove this access list from here, say no access list 10, and I am going to create this access list on router number 2. Access list number 10 deny 10.1.1.1, right? Access list 10 permit any rest traffic should be permit, and interface f0/0 IP access group number 10 and direction out. Here I have applied this access control is in out direction on fast Ethernet 0/0. Again from PC1 I am going to ping 30. Ping is working, but I cannot ping 20 user. 20.1.1.1. See, I'm not able to ping because this time router 2 is filtering traffic on this interface, right, where source is 10.1. So whenever router 1 will see source IP is 10.1, it will not allow to move from this interface, right? So if you want to block communication between a particular host to particular host, you have to create what? Extended ACL. Because in extended ACL we can filter traffic on the basis of source IP, destination IP, right? But in extended ACL we can filter traffic only on the basis of source address. So here on router number 2 I'm going to say no to this access control list. No access list 10. And on router 1 I'm going to create extended ACL now for blocking the traffic of 10.1 to 10. To 20.1 only. So access list number, let's say 101, deny source 10.1.1.1 wildcard mask 0.0.0, destination 20.1.1.1 wildcard mask of destination 0.0.0. And here you have to define protocol as well. Deny, then protocol. Which protocol? Let's say I want to deny IP packet, then source 10.1.1.1 wildcard mask 0. And here you can use host keyword also. Like if you want to block a particular IP address, you can say host 10.1.1.1, destination host 20.1.1.1. That's it. Then access list 101 permit IP any. And now if I will apply this access list on fast Ethernet 0/1 IP access group 101 direction out. Now PC 0 cannot ping to 20.1, right? This time router 1 will block the traffic by checking source as well as destination. Router 1 will block only that traffic where it will find source 10.1 and destination 20.1. For any other destination, let's say for 20.2, you can see ping is working, ping will work. Earlier in extended ACL, router was checking only source address, right? So here you can see ping is working. So that's why I have applied extended ACL on router number 1. Because if I will apply extended ACL on router number 2, then also it will work fine. But on the link, again router will forward the traffic. So if we need to drop the traffic, it will be better if I will drop on router number 1. So that's why it's recommendation you should apply extended ACL nearest to the source. Right? Again I am going to allow it. So say no. Sorry, router number 2 on router number 1. No access list 101. Interface F0/1 say no IP access group 101 direction out. Now let's say what I want, 10.1 should be able to communicate with this server. This user should be able to ping this server, but this user should not be able to access HTTP service. So this time I want to block a particular service. Again, I have to use what? Extended ACL. We cannot achieve it with the help of extended ACL. Or let's say on these router telnet service is enable. Let's say on router number 3 I'm going to enable telnet. So by default telnet is enable, only I need to configure password. Line VTY 04, let's say password 123 and say login. Right? Now this user can access router 3 telnet, and IP address of router 3 is 23.1.1.3. See, it's asking for password. I am able to access router 3. But what I want, PC 0 should not be able to access router number 3, right? But router, this PC should be able to ping router number 3. So what I can do, I can create extended ACL, right? On, let's say on router number 1 I am going to apply extended ACL to block telnet traffic. So what I will do, access list 101 deny. Which type of traffic? Telnet is TCP based, so denied only TCP traffic, right? Then source host 10.1.1.1, destination host 23.1.1. or we can say destination any also, like any. After that, equal to which port number you want to block. Telnet port number is, what is the port number of telnet, guys?
23.
Access list 101, permit IP any, and interface F0/1, IP access group 101 direction out. Now you can see from PC number 1, if I will try to access, telnet, see, I'm not able to access telnet. But again from PC number 1, telnet 23.1.1.3 I'm able to access. Again from PC number 1 I can ping 23.1.1.3 IP address. See, ping is working. In the same way, if you want to block a particular service on this server, let's say on this server I am going to enable HTTP service. HTTP by default HTTP service is on, and from PC 0 you can see I can access HTTP server. In the browser I will type IP address of HTTP server.
Can you add log to the access list?
Sorry,
Add log to the access list.
add log.
Yes.
Add log means
Log keyword at the end of the access list. That
log option is not here.
equal 23 access list, you gave that command, right? Equal to telnet 23. After that, if you put log, it will show who logged in. Yes.
No, I'm not getting log option here.
Oh.
What is log? What will happen then?
The log will show who logged in.
No, I
Who
don't
is
know about
trying to
that.
log, like that, the log message will come.
Okay, I don't know. Okay, so here from PC 0, if I will type IP address of HTTP server here 30.1.1.1, you can see I am able to access HTTP service on this server. But again I want to block HTTP service, let's say for all user in this network, or for all user in this network. So I can apply access control list on router number 2. So let me create one access list on router 2. Access list 101 deny, again TCP, source is 20.1.1.0. This time I am defining complete network. Wildcard was 0.0.255. Destination let's say NE, and equal to port number 80, right? Then access list 101 permit IP NE, right? Now I can apply this access list on, let's say, 0/1 interface, F0/1, say IP access group 101 direction out. From PC number 2, first try to ping server, ping 30.1.1.1. I'm able to ping. Now let's try to access HTTP service. Thirty dot one dot one dot one. See, 30.1.1.1. So access list, we don't have any match. Oh, I think I have apply access control list on 0/1 interface. So run. So I have apply access control list on 0/1 interface. So let me correct it. Interface F0/1, no IP access group 101 direction out, and I am going to apply it on F0/1/0 IP access group 101 direction out, right? Now if you will try to access this server, whatever, 30.1.1.1. So you can see I'm not able to access HTTP service. So this is how we can block a particular service with the help of extended ACL.
Do we need to apply at F0/1 in direction?
F0/, yes, you can apply it in
So
interaction also here.
R3
On R3 also, if you will apply it on this interface,
in
the
direction.
action should be in. If you will apply it on in this interface, the action should be out. On router number 2 also, you can apply on this interface as well as on this interface. If you are applying it on 1/0, the action should be out. If you are applying it on 0/0, the action should be in.
We have to apply close to the destination, right? So R3 we have to apply
Closest to the source.
closest extended.
Yes.
Okay.
Okay.
So standard should be applied closest to the destination and extended should be applied closest to the source. Am I right?
Correct.
Okay.
Okay, guys. Can I close this lab?
How to enable SSH?
Are you asking for command?
Yes.
Here are command. And in my file also you have command. There is command to enable SSH. For all protocols. Read this. Use this IS file. Here it is. These are command. Okay.
Okay, can you share this one?
You have already. By the way, let me share again.
Okay. We learned a lot today.
Hmm. Today I have covered four topics, na?
On bigger topics, GLBP,
HSRP, VRRP,
mm,
and access control list.
IPSLA.
IPSLA. Now your time to perform lab.
If you have doubts, we can ask in the group or
Yes, you can ask in group. You can ask in group also. You can message me on personal also. But don't message me on my 96 number, right?
which number we have to message you.
On this number, 8511. On this number.
Okay.
Okay. Any other? Yes, yes.
Yeah, Prabul, I need that. Can you share me that PPT that which you share now access list some theory of.
Okay. Okay, okay. Sure. Okay, guys. So our course is finished.
Happy New Year, sir.
Same to you.
Happy
Happy
New
New Year
Year
to
Happy New
all.
Year, everyone.
for all.
Happy New Year to all.
So we will have WhatsApp group, right, for conversation. So you guys can also, communicate with each other, and you guys can also solve the query of others, and I will be also there, right? So if anyone will have dot, it will be better if you will share it in group, right? So others people can also help to anyone to to people who have problem, and I will be also there definitely. Then sometime I will provide you some videos on important topic, like whenever I will make important video on, let's say, security or on ASA firewall, or any topic like, let's say, IPsec. Okay, so I will share link of that video in group, and guys, please keep watching those video also, right?
ASA
I will not
firewall.
share all videos.
ASA firewall means it will be based on extended access list, right?
ASA firewall.
Mm.
ASA firewall also you can create extended as well as extended.
Concept will be like this.
Yes, concept will be like this. Okay, there is concept of security zone. Like your inside zone will have security level 100. Let's say this is your firewall, right? This is LAN interface. So this interface will have security level 100, and this is WAN interface, right? So this interface will have security level 0. So by default, traffic from higher security level to lower security level can move, but traffic from lower security level to higher security level can not move. So outside user cannot forward any traffic in LAN by default, right? For that, here you have to configure something. So guys, if you are completely fresher in ASA, I will recommend you to watch at least 10 videos on my YouTube channel, right? On ASA firewall, I have uploaded 10 videos. There is basic configuration and basic uh, theory part of ASA firewall, so you can watch those videos. Otherwise, in future, definitely I will add, upload some more videos on security on different firewall as well, right? How was the training, guys? How many of you learned something?
I learned a lot.
Anyone who is thinking, I have not learned anything new in this course?
For me, it's good if you covered some firewall concepts. It's great for us.
No, here I will not cover firewall concept. For firewall, you can watch my YouTube videos. If you will have doubt, definitely I can help you.
Yeah, thank you. Thank you.
Even I learned a lot. Okay. Thank you, Ji. Thank you so much.
Thank you, thank you. Okay, so I'm not going to delete WhatsApp group. We will have WhatsApp group, guys. We will in connect for lifetime. Okay. I will
Okay.
add
Thank you,
maybe
yeah.
another tenor as well in the
Thank
group.
you, Prabhu.
Welcome, welcome. And now, guys, by then, that's all. Happy New Year again
Okay.
to everyone.
Thank you.
Thank
Thank
you
you.
and
And
wish you the same.
Happy New Year to
okay,
all. Okay. Thank you.
thank you, thank you.